This video is over lesson 84, selecting an appropriate rational number, and it is for my pre-algebra classes. First of all, a rational number is any real number that can be written as a fraction with integers where the denominator is not 0. So just a quick reminder on integers. So integers include all counting numbers or natural numbers. So 1, 2, 3, 4, 5, and on and on and on. Integers also include the opposites of all these numbers. So -1, -2, -3, -4, -5, and on and on and on. But then integers also include a third category, 0. So all the natural numbers, their opposites, and 0. So if you can take a number and rewrite it as a fraction using these numbers, but not 0 in the denominator, then that is a rational number. So rational numbers then are going to include, first and foremost, integers. Since every integer is itself over 1, well, 1's an integer, so therefore if you put an integer over 1, that's still a rational number. This also is going to include normal fractions. And now that's not an official description, but if you think about the normal fractions that you're used to seeing, they involve integers. Normal fractions, and for that matter, normal mixed numbers as well. So integers, normal fractions are going to be just fine. So speaking of fractions, related to that is going to be then other numbers that involve a piece of a whole. And so the other way that we write a piece of a whole is as a decimal. And so with decimals, we have to do some considering. So if I consider, let's say 0.4, well, I know that that's going to work because that's just going to be 4 over, and then this is the tenths place, so 4 over 10. If I have 0.25, well, that's a 25, but then it goes to the hundredths place. Now, both of these are called terminating decimals. Terminating meaning that their non-zero digits eventually come to an end. Terminate means to end. So if you think about the movie The Terminator, he's a machine that goes around and terminates people. He ends them. He ends their lives. I'm not recommending you go see it, but hopefully that at least gets you a little connection there with what terminate really means. So terminate means to end. These are terminating decimals. And so all terminating decimals are going to be their decimal parts over their final decimal place. So this is at the tenths, tenths. This is at the hundredths, hundredths. And so all of our place values are going to be related to powers of 10, which are all integers. So that means all terminating decimals will also be integers. Or it's going to also be rational. So terminating decimals. We can also call these finite decimals. So typically called terminating decimals, but they can also be called finite decimals. So finite decimals work, so how about infinite decimals? Well, the first infinite decimal you may think of would be repeating decimals. Repeating decimals, let's take a look at an example. Let's say I have 0.1 repeating. Well, you may or may not remember from previous lessons that this is actually 1/9. And for that matter, if I just change this to 0.2 repeating, this will become 2/9. And likewise, if I change it to 3 repeating, that becomes 3/9, and so on and so on and so on and so on. So at least if there's only one repeating digit, we know that it's going to be rational because 2 and 9 are both integers. 1 and 9 were both integers a moment ago. 3 and 9 would be both integers if I were to go there, and so on and so forth. So what happens if I have other things? other repeating digits with it. So like 0.14 repeating. Well, it turns out that this is actually 14 over 99, and perhaps you can begin to see a pattern here. If I were to ask you, could you make me a fraction for 0.257 repeating? Maybe some of you are starting to catch on here. This would actually be 257 over 999. So it turns out that if you have a decimal, a repeating decimal where all of its parts repeat, all of its digits repeat, you can just take those digits, the repetend, put it as your numerator, and then you take the number of digits you have, and that's the number of nines you have in the denominator. So it's actually kind of simple if they all repeat. Now it gets a little bit more complicated when we have things that don't repeat. The easiest way to look at this is if I have just a 0 that doesn't repeat. Zeros are convenient here. And so what would happen here is I would have 0.07 with the 7 repeating. The repetend would be my numerator still. There's only one digit repeating, so that'd be a 9 on the bottom. But then since we have that 0 there, that's kind of creating a space. We have a 0 there as well. So 0.07 with the 7 repeating is actually 7/90ths. If I were to do 0.00123, let's go with that, repeating. Try to get this out of my bright spot there. So this actually would be, well, 1, 2, 3 over, and now I have 3 digits repeating, so that means there's going to be 3 nines, but then we were shifted over 2 spots, so I'll have 2 zeros there. So this is actually 123 over 99,900. And we could do a little reducing there, but that's at least to get us started. So what if I have something other than 0, though, that doesn't repeat, like 0.16 with the 6 repeating? Well, in this case, we kind of break it up into 2 pieces. We kind of think of it as, I can get my red here, as 0.1 plus 0.06 with the 6 repeating. So we'll kind of break it apart. So the 0.1 here would just be 1/10. The 0.06 with the 6 repeating would be 6 over, well, single digit repeating, so that's a 9, and it's offset by 1 spot, so that's a 0. So then if we simplify this a little bit, well, first of all, I can see that I can do a little reducing there. 3 goes into both of those, so that'd be 2, and that'd be 30. And then that creates a nice common denominator there, so I actually might stop right there and go with 30 as a common denominator. So then this would be 3/30ths plus 2/30ths, which is 5/30ths. And then, of course, we can reduce that down to 1/6. So this actually comes out kind of nicely this time. They're not always going to come out that nicely. So ladies and gentlemen, notice that I'm doing this all on the dry erase board. If you didn't follow what I was doing there, that's okay. It's not actually part of the lesson and the homework. But the point that I'm trying to build up to is, it turns out that repeating decimals actually have a fairly simple formula for converting them into fractions. The difficulty, though, is reducing some of those fractions. Some of them kind of be difficult. And just real quick to illustrate that point, if I were to give you the repeating decimal 0.142857 repeating, well, this would be 142,857 over, and there are 6 digits repeating, so 6 nines on the bottom. That's what it would be. But then if you were to try to reduce that, you might have a little bit of difficulty, especially if I tell you that in the end, somehow you're going to get down to 1/7. Now, if I didn't tell you that and you didn't have it memorized, I imagine you'd struggle a little bit to figure out exactly how to simplify that. So, easy formula to make fractions, not always easy in the reducing. So, generally speaking, that's part of the reason why we stay away from repeating decimals. However, that's not the issue today. Today, the issue is that they're a rational number, that you can turn them into a fraction using integers. So repeating decimals. Now, they are a type of infinite decimal. They go on and on and on. However, I'm not going to write infinite after that because they're not the only kind of repeating decimal. It turns out that if you want to talk about irrational numbers, so the prefix ir means not, so not rational, then it has to not be any of these things. So irrational numbers are not integers, they are not normal fractions or mixed numbers, which means that if they're not integers, and I can't write them as a normal fraction or mixed number, they've got to be a kind of decimal. But they can't be a finite decimal, so that means it's got to be an infinite decimal, but it also can't be a repeating decimal, which means that irrational numbers must be an infinite, non-repeating decimal like pi. But again, that's not the point of today's lesson, so let's keep moving. The last thing I want to put in our category here has to do with the fact that if you take a rational number, so you could write it as a fraction, and if you were to multiply that with another rational number, so you'd have basically an integer on top with times another integer on top, and an integer on bottom times another integer on bottom. Well, when you multiply integers, you just get another integer. So that would mean that when you multiply those together, you're going to get another rational number. Likewise, when you divide rational numbers, you're going to end up with another rational number. So the last thing I want to discuss here is, speaking of parts of things, we've talked about fractions, we've talked about what kind of decimals are rational. I also want to talk about percentages. The third way that we describe a piece of something is as a decimal. And decimals, it turns out, are rational so long as the percentage itself, the number in the percentage, is rational. So if you were to take away the percent sign and you'd have a rational number, then with the percent sign, it's still rational. If you were to take away the percent sign and it's irrational, then with the percent sign, it's still irrational. So with this being said, we're going to take a look now at the practice problems from the book. So if you would open up your book to page, I believe that's 565, and we're going to take a look at the practice problems here. So in your notes, please go ahead and write practice. And if you haven't gotten to page 565, go ahead and pause, look that up, and then hit play again. All right, here we go. A. Find 20% of 1/4 of $12. So my first task is to copy this problem down. So it's asking me to find 20%, so I'm going to write 20%. Then it says of, which means times, 1/4. Then it says of again, so times, and then $12. Which we don't need to write the $12 with the decimal and 2 zeros. It's the same as just the whole number 12. So save some writing. Now we've got a decision to make. And that's kind of the point of today's lesson, is thinking about what would be the most appropriate form of my rational numbers. Because if I'm multiplying by 12, particularly with the 20%, do I want to change this into a fraction or a decimal? Now, if I change it to a fraction, it matches the 1/4, and we're probably good to go. But if I change this into a decimal, then I probably want to do the same with 1/4. So whatever we do, we want to be consistent. So because it's money, typically when it comes to money, when we write our final answer, if it's not a full dollar amount, we express money using decimals. So normally with money, we want to go the decimal route. So I'm going to think about 20%. Well, percent means divide by 100, so if I divide by 100, that would scoot the decimal over 2 times. So my 20% is really 0.2. Now 1/4 here, I would imagine you should have memorized as 0.25. And then times $12. So now we're going to go ahead and multiply these together. And I bet that you actually probably could do this as mental math. And so remember that when we multiply by decimals, we ignore the decimal until the end. We're going to treat this like whole numbers. So I especially like the 25. It makes me think of quarters. So one way that we could do this is we could take 25 and multiply it by the 2, so that would give me 50. and then take 50 and multiply it by 12. So 5 times 12 is 60. So 50 times 12 would be 600. But then we'd have 3 decimal places on my 600. So with 3 decimal places on my 600, that's going to put the decimal right in front of the 6. Remember, this is money, so if the decimal is right in front of the 6, we actually will need one of those zeros. So my final answer there is 60 cents. We're going to do this one more time. Copy it down again. This time, though, let's just see what would happen if we decided to go with fractions. So if I decided to go with fractions, I know that 20%, well, 20 divided by 100 really, is 20 over 100, and that reduces down to 1/5. And then I would have times 1/4, and then I would go ahead and throw 12 over 1. So then I'm going to do a little reducing before multiplying. So 2 goes into both of those, and I'll get a 2 and a 6 out. And now we can go ahead, and I'm actually going to leave it right there because I like the fact that 5 times 2 will give me 10. So even though I could have reduced both of those by 4, I like the 5 times 2 here, because then 6 over 10 would be my result, which of course if we divide by 10, that means we just move the decimal once. Now, could you have reduced those both by 4? Absolutely. Okay. But I chose not to because I thought it'd make it a little bit easier for me. So if I move that decimal over, I'm going to get 0.6. But remember, since this is money, I need that extra 0. So both of these actually work kind of nicely, depending on how your brain works and how you make connections. You might have found the decimals easier, or you might have found the fractions easier, or perhaps you found them just as easy as each other. Generally speaking, decimals are usually best, oops, forgot my T, best for money. Decimals are usually the best option because we're working with money there. Not always, but usually. All right, we're going to go on to B. I'm going to ask you to skip 2 lines there just to give a little extra space, kind of disconnect those a little more. So B, Irina, I believe that's how you say that, Irina made 85% of her free throw attempts. She missed only 6 free throws. How many did she attempt? So we're going to translate this problem into a math statement. Oh, I'm sorry. So sorry, that's number 2 on the homework. I looked at the wrong place on my page. Let's go back to B. Let's go back to B. So B, find 33 1/3% of 3/8 and $12. So 33 1/3% of means times. 3/8 is 3/8, and then times $12 again. There we go. There's the right problem. Now, ladies and gentlemen, with this one, I would say you don't really have an option here. You don't really have an option. And the reason for that is because you may have it memorized. If you do, it's going to be convenient here, that 33 1/3% is 0.3 repeating. Do not use repeating decimals. Don't do it. So because 33 1/3% would be a repeating decimal, yes, it is a rational number, but we've never really learned how to multiply with repeating decimals properly. Largely because when you're working with them, you basically have 2 options. One option is to round them off, which we don't want to do here. Do not round them off. But then the other option is we change them into fractions. So in the end, if you're just going to change it to fraction, just go with the fraction. So our only real option here is to go with the fraction. So 33 and 1/3%, hopefully you also have it memorized that that is 1/3. This means I get to leave my 3/8 alone. And then I'm going to throw 12 over 1, just like I did last time. Now here, I notice that 3 and 3 will both turn into 1s. And then I'm going to go ahead and reduce these both by 4. So I get a 2 and I get a 3. And so my end result, I got 1 times $3 is $3. Over 1 times 2 times 1 is 2. And of course, 3 divided by 2 is 1.5. But since it's money, I will have to have an extra 0 there. So the answer to this problem, what is 33 and 1/3% of 3/8 of $12? Well, it's $1.50. And so the best rational number in this case was a fraction, because we want to avoid repeating decimals. All right, let's skip a couple lines there. We'll move on to C now. For letter C, I'll make sure that it's letter C this time and not number 3. Letter C, to find 80% of $21.50, would you convert 80% to a fraction or a decimal, and why? And so as we discussed here, since it's money, typically we want a decimal. However, this time we have an extra reason to want a decimal, and that's the fact that the money is not a whole number amount. So $21.50 is already a decimal. So my answer here, I would convert 80%, so it's good to incorporate the question as part of your answer. I would convert 80% to a decimal to find 80% of $21.50 because decimals are usually best for money, and also because $21.50 is a decimal. So a sentence on your homework should look something like that. We're going to move on to D now. I'm just going to skip a single space here for D. I don't feel the need to do a double one again. So D, to find 25% of $24, would you convert 25% to a fraction or a decimal, and why? So again, we could go with the same answer that we had for C. We could say that we'd make a decimal because, well, money. But this time, actually, it might be better to go ahead and make that a fraction. You probably have it memorized that 25% is 1/4. So finding 1/4 of something is basically dividing it by 4, which, since 24 divides nicely by 4, that sounds like a really good option. So this time I would go with a fraction. So I would convert 25% to a fraction to find 25% of $24 because 25% is 1/4, and 1/4 of $24 is mental math. It can be done easily. It's mental math. So 1/4 of $24, 24 divided by 4, must be $6. And finally, E. Which expression is the most appropriate rational number to announce a discount of $14 from a regular price of $40? So we can save 7/20ths. We can save 0.35, or we can save 35%. Well, I imagine, ladies and gentlemen, you have been out and about in the world long enough to realize that typically the way we describe a discount like this is as a percentage. And so that percentages basically tells me, 35% tells me that for every dollar, I'm going to save 35 cents. Okay, but keep in mind that this is a percentage, so if we've got pieces of a dollar, then we're going to save pieces of that dollar. So if I have try to buy something on 35% off, and it's worth 50 cents, well then 35% of that, well, you're going to have to actually find that mathematically. So just like it's half of a dollar, you're going to save half of 35 cents. So percentage is the best way to express that. And that, ladies and gentlemen, is the end of our lesson.